Alright, this is lesson 1.10 of our Precalc 11 class. Unit 1 is called Radicals and Rational Exponents. Lesson 10 is called Negative Exponents. What we're going to learn in this video is how do we understand what a negative exponent means, and then how to simplify expressions that contain negative exponents. Alright, quick exercise to get our brains warmed up for negative exponents. Complete the table. I've already completed it for you in class, but take a moment, read through the patterns. Each row is equivalent, so 2 to the power of 3 is equal to 2 times 2 times 2, which is equal to 8, and so on. Notice each row we go down, we divide by 2. If I take 8 and divide it by 2, I get 4. In the middle column, that means I get rid of one of the 2's, or divide 2 by 2 by 2 by 2, I have only 2 2's left. In the first column, it means we subtract 1 from the exponent. In the next row, to go from 4 to 2, we divide by 2. In the middle column, that means we have 1 less 2 being multiplied. In the first column, it means we're subtracting 1 from the exponent. So if we continue that pattern, dividing by 2, we get 1. Dividing by 2 in the middle column, we get 2 over 2, which is equal to 1. And in the first column, we subtract 1 from the exponent. So 2 to the power of 1 minus 1 is 2 to the power of 0. If we continue that pattern, again, 1 divided by 2 is 1/2. Same thing here. And we take 1 off of 0, we get 2 to the power of negative 1. Dividing it by 1/2 again means we're multiplying the denominator by 2 again. 1/2, 1 over 2 times 2 would be 1 over 4. Subtract 1 from the exponent, and so on. Do it again. Notice the pattern 2 to the power of 3 looks like 2 to the power of negative 3, except they're reciprocals. So 8 versus 1 over 8. Which means, if you take just this last example, 8 is 2 to the power of 3. So we could write 1 over 8 as 1 over 2 to the power of 3. Well, that looks like this thing, except you put the 2 to the power of 3 in the denominator, and you get rid of the negative sign, and that's the same thing. So we're going to take advantage of that fact right here. So instead of 2 to the power of negative 3 equals 1 over 2 to the power of 3, or 8, we could generalize it. So any number to any negative power is equal to the reciprocal, but with that power being positive instead of negative. My non-politically correct way of saying this, and it's terrible parenting advice, so don't ever do it, but it helps stick it in my head. If you have a negative child, you put them in the basement until it becomes positive. Again, don't ever do that to your children. It's not good parenting advice. Alright, so we have a few examples here, brackets and no brackets. We're going to exercise here is to write them as positive exponents only, and then write them again as radicals. So notice in the first example, there's 4 times x to the power of negative 2/3. Because there's no brackets, the negative exponent is only on the x. Unlike the second example, where the 4x is in brackets. In this case, the negative 2/3 is an exponent on each base. So 4 to the power of negative 2/3 and x to the power of negative 2/3. And we can see how how the brackets change the answer accordingly. Same thing if you put each of these, the reciprocals of each of these, the third and fourth example, we can see how that changes the answer. Take a moment, make sure these make sense to you. One quick note on the second example in blue. We could simplify this a little further, because the 16, the third root of 16, 2, 4, 8, 16, there's 4 2's in there. So I could take 3 of them out and write this as 2 times the third root of 2x squared. So that one could be simplified a little further. We did it in the third example. I just didn't go back and do it in this example, so I'm sorry. Okay, some examples. The first thing I'm going to do is simplify the thing inside the radicand, or the radicand, which is the thing inside of the radical. I have common bases of x. They're both in the denominator, so I'm going to combine them, add exponents, write it as a negative exponent to get 16th root of x to the power of negative 6. And now that I have a single base in there with a power, I'm going to write this as a rational exponent. The exponent is negative 6 over 16. And then I'm just going to simplify the fraction and call it fully simplified. We're going to do an analogous process for the rest of these. I'm going to simplify all these y's inside the brackets. And then I'm going to write it as just an exponent on a y. And then I'm going to use my exponent properties to combine the exponents. Simplify the fraction, and we're done. Take a moment, read through these examples, pause the video if you need to, and we're going to move on. Alright, some more examples. We're going to do, we have example A, we're going to simplify the expression using only positive exponents. We have a negative exponent in example A, so we're going to take care of that. We're also going to distribute the exponent outside of the brackets to each base. 125 is our first base, so it's going to be 125 to the power of 2/3. X is our second base, and it already has an exponent, so we're going to multiply exponents. And then y is our last base, which also has an exponent of 18. So we're going to multiply that by 2/3. 125 is a number I can pull an exponent of 3 out of, 5 to the power of 3. So we're going to multiply those exponents, multiply these exponents, and multiply the exponents on the y. We'll get our 3 fractional exponents that we can simplify. When we simplify them, we have 5 squared, we have x to the power of negative 16, and we have y to the power of 12. The x has a negative exponent, so we're going to rewrite the reciprocal of just the x with a positive exponent. Or we're just going to put that negative exponent in the basement. Here's our fully simplified answer using only positive exponents. 25 y to the power of 12 over 16 to the power, or sorry, x to the power of 16. That. We're going to do a similar process for the example B and example C. So take a moment, read through those. Notice in example C, there's 2 ways you could write the final answer. Both of these answers meet our criteria for fully simplified. We have exponents that are fully simplified, and we have positive exponents. But you can put the 1/27th as a coefficient out front, or you can make the x and y bases a fraction over 27. I think both are equal. Either answer, if this was a quiz question and this was the directions, I would say either answer will give you full credit on your quiz. If you give both answers, will I give you extra credit? No. Sorry, that was a letdown. Anyways, but good on you for putting both. I will notice and appreciate it. Alright, takeaways for this lesson. We now know what negative exponents are. We have an understanding of how to work with them and how to simplify expressions that contain negative exponents.